Welcome back to Smart Web, your daily dose of GMAT Quant practice. Let's dive into today's question. It says that 10 nominees for 3 business awards are randomly seated at 10 places at a round table. 3 of these nominees are then called up together to receive 3 awards. What is the probability that no 2 adjacent seats will be left empty? That means there are 10 nominees. If we understand, there are 10 nominees which have to be given 3 awards, right? And these 3 people or 3 nominees, they should not sit together such that no adjacent seats will be left empty. They have to be seated such that no 2 nominees who have got the award, they are not sitting together. That's the question all about. Let's consider that there are 10 people, A, B, C, D, E, F, G, H, I, and J. So these are 10 people who are to be seated around a round table. In how many ways these 10 people can be seated around the table? Now we know that n distinct objects, they can be arranged. Objects can be arranged around a table, in n minus 1 factorial ways. That means if 10 people are there from A to J, how many ways they can be seated around a table? So total number of ways, total ways in which they can be seated will be 10 minus 1 factorial ways, which is 9 factorial ways, right? In these many ways, 10 people can be seated. Now the question, what are the favorable number of outcomes? It says that no 2 nominees who have got the award, they should sit adjacent to each other. Let's say that A, B, C are 3 nominees who got the award. That means remaining 7 do not get, right? Now, first make them sit. If A, B, C are not to be seated together, first make rest of the 7 seated. In these type of questions, just apply this and you will get the answer. Just make them, 7 of them, sit on the 7 positions. So let's say D, E, F, G, H, I, and J. So in how many ways 7 objects they can be seated, right? In how many ways they can be seated? 7 objects can be seated around a table in 7 minus 1 factorial ways, right? Number of ways in which 7 people can be seated. 7 people can be seated. That is 7 minus 1, that is 6 factorial ways. Now you have made 7 people seated. Now, what are the positions for these 3 people such that they are not together? That means you have created this position, this, here, this one, and this one. That means there are how many positions in which ABC can be seated such that they are not together? 1 position here, 2nd, 3rd, 4th, 5th, 6th, 7th. So that means you have created 7 positions. Out of them, you require 3 for these 3 objects, that is ABC, such that none of them are together. None of them are together, right? ABC should not be together. And what are the favorable positions for them? That are these 7 positions on which if they sit, they are not together and the seats will not be empty according to the question. So in how many ways you can pick 3 chairs or 3 positions out of these 7, that is 7p3. Why? Because it's a permutation. The order matters here. So number of ways in which ABC can be seated, ABC can be seated will be 7p3. Why? Because there are 7 positions to be picked for 3 positions, right? There are total 7 positions and you require 3 out of them. Order matters. Therefore, it's a question on permutation. So the total number of ways in which you can pick 3 positions out of these 7 for ABC will be 7p3. So total number of, or our favorable number of outcomes, we have to find out the probability. Coming to the question now. Now, probability is Favorable number of outcome. What is the favorable number of outcomes? Let's write it here. Favorable number of outcomes, required probability. What is the required probability? We'll be having probability as favorable. What is favorable? That these two should not, out of these three, they should not sit together, right? None of these three nominees who got the award, they should be seated together. That's the favorable number of outcomes. So I've made first these 7 sit in how many ways? That is 6 factorial, and out of these 7 you require 3. In how many ways you can pick? 3 positions out of 7, order matters, that is 7p3, divided by total number of, how many total number of outcomes? 10 people can be seated around a circular table in 9 factorial ways. That's our required answer. Let's now solve this. The 6 factorial as it is, 7 factorial we can write as 7 factorial over 7 minus 3, that is 4 factorial, over 9 factorial can be written as 9 into 8 times 7 times 7 times 6 factorial. 6 gets cancelled out. Let's simplify this further. So what's the numerator now? That is going to be 7 factorial. 7 factorial can be written as 7 times 6, 5 into 4 factorial divided by 4 factorial. 4 factorial times 9 into 8 into 7. 9 times 8 times 7. Solving this further, simplifying, 7 gets cancelled out. Simplifying this, 2 3s are 2 4s are 3 3s are 9. That means it comes out to be 5 upon 12. That's the required probability. Option C is the correct answer here. If you found this video helpful, give it a thumbs up.